Hi everyone. In this video, we would discuss the concepts and connection of determinant, minor, cofactor, and adjoint in a simplified manner. Imagine I have a matrix A, which is a 1 by 1 matrix. To find the determinant of matrix A, now the notation of the determinant is like this, which looks like an absolute value, but it is not an absolute value. It is the determinant of a matrix. And the determinant of a 1 by 1 matrix is the element itself. So the determinant of matrix A here is the value 5. The determinant of a matrix gives us a unique value in relation to the matrix itself. So let's find the determinant of matrix B here. The determinant of matrix B would be the value of the element itself, which is negative 5. Now, the determinant of a 2 by 2 matrix is calculated in a different manner. It also gives us a single unique value, but we have a formula for the calculation of the determinant itself. Now, imagine if we have a matrix F, a 2 by 2 matrix with element 1, 1 as A, element 1, 2 as B, element 2, 1 as C, and the final element as D. The determinant of matrix F would be the multiplication of A and D minus the multiplication of B and C. And so the final value would be AD minus BC. Let's look at this example here. So the determinant of this matrix would be 1 multiplied by 4 minus 2 multiplied by 3, which is 4 minus 6, and this gives us minus 2. Next, we have the minor. It's written in this form, capital Mij, where I is the row of the matrix and J is the column of the matrix, of an element Aij. So the element refers to the element of matrix A here. So the minor from a matrix A is the determinant of the matrix obtained by deleting the ith row and jth column of the matrix. Let's look at an example. If my objective is to find the minor of the element A13, then I would delete row number 1 and column number 3 and find the determinant of the matrix that is obtained by deleting the first row and the third column of this matrix, which is A21, A22, A31, and A32. So the minor of the element A13 would be A21 multiplied by A32 minus A22 multiplied by A31. Next, I would like to find the minor of element 22. So first, we locate the element A22, which would be the value 5 here. So now I'm going to delete the second row and the second column. And this is A22, right? So the minor of A22 would be the determinant of the matrix that is remaining from the row and column that has been deleted, which is 1, 3, 7, 9. And this gives us 1 multiplied by 9, which is 9, minus 7 multiplied by 3, which is 21, negative 12. When we have a 2 by 2 matrix, the minor is found in a similar way. So the minor for element A22 could be found by first locating the element itself, which is this one here. And next we would delete the row and column related to the element. And finally, find the determinant of the matrix that is left here. So we only have a 1 by 1 matrix here. So the determinant of matrix 3 would be 3. And remember, if the value here is minus 3, then the answer would be the determinant of the matrix minus 3, which is minus 3. The cofactor denoted by Cij of an element Aij from matrix A is given by the following formula. Negative 1 to the power of I plus j multiplied by the minor of the element. I would like to bring your attention to the expansion of this formula. Imagine if we have a 3 by 3 matrix. Okay, so we would start with the first element. So element 1, 1, I would be 1 and j would be 1. So negative 1 to the power of 2 would give us 1 multiplied by the minor of the element, A11. Next, we have negative 1 to the power of I would be the first row, row 1, and j would be column 2. So 1 plus 2 gives us 3. Negative 1 to the power of 3 would be negative 1. And the minor of A1, 2. So class, the value negative 1 to the power of I plus j here is quite easy to memorize. It starts with the value 1 and then minus 1, 1 again, minus 1, and then 1, minus 1, 1 again, minus 1, and 1. Let's try out an example. So the cofactor for element 1, 1 here would be, I think I would start with whether it's positive or negative. This would be positive 1, negative 1, positive 1, and so on. So it would be positive 1 multiplied by minor of the element 1, 1. So a minor we find by deleting the rows and column associated with the element and find the determinant of the remaining matrix, which is 5, 6, 8, 9. Now this gives us 5 multiplied by 9, 45, minus 6 multiplied by 8, 48, and we get negative 3. Next, the cofactor of element 2, 2, which is located here. So this will be positive 1, negative 1, positive 1, negative 1, and positive 1. We have positive 1 multiplied by the minor of element 2, 2. So to find the minor, delete the rows, the columns and rows associated with the element. Find the determinant of the remaining matrix. We have matrix 1, 3, 7, 9. And this gives us 1 multiplied by 9 is 9 minus 3 multiplied by 7, 21. The answer would be negative 12. Now, we would like to find the cofactor of element 3, 2. So first let's locate the element 3, row number 3, column number 2. So this is the element. We have plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, and minus 1. So negative 1 multiplied with the minor of element 3, 2. So to find the minor, delete the column and rows associated with the elements. Find the determinant of the remaining matrix. But we have negative 1 multiplied by that. So negative of the determinant, we have negative 1 multiplied by 6 is 6 minus 3 multiplied by 4 is 12. So we have negative of negative 6, which gives us 6. Okay, we have discussed the determinant of matrix 1 by 1, the determinant of matrix 2 by 2 using formulas, right? And now we would learn how to find the determinant of any square matrix. So a matrix needs to be a square matrix in order to find the determinant. This is an important criteria. And remember, the determinant is a unique value associated to the matrix. So there are two ways to find the determinant of a square matrix. We could either expand the cofactors along the row of a matrix or expand the cofactor along the column of a matrix. So any row or any column that belongs to the matrix. Let's look at this formula. Imagine that I would like to expand the cofactors along the first row. So the first row, I would be 1. That means the determinant of matrix A, if it's a 3 by 3 matrix, okay, class, 3 by 3 matrix. So the determinant of matrix A would be the summation of J, column J, from 1 to n would be 3. Okay, I is 1, 1J multiplied by A1J. So Aij or A1J would be the element itself and C would be the cofactor. So we have a 3 by 3 matrix. J starts from 1 to 3. And we have the determinant of matrix A as C11, A11 plus C12, A12 plus C13, A13. And similarly for the column, let's say I would like to expand along the second column. So J would be column 2. Okay. The determinant of matrix A would be summation I starting from 1 up to n is 3 because we have a 3 by 3 matrix. And I'm just going to copy this. J is equals to 2, I2. So this gives us I from 1 to 3. So C12, A12 plus C22, A22 plus C32, A32. Now, the formula might look complicated and all, but trust me, the process of finding the determinant of any square matrix is very easy and I'll show you in a short while. Okay, so let's try out the formula that we had just now. if we would like to expand along a row. Now, when we choose any row or column, it's best that we choose something that has a 0, because as you will see later on, we would minimize our calculation time when we have a 0 along a row or column in the cofactor expansion. So let's start with the easiest one, the first row. Okay, and if you still remember, the formula was C11A11 plus C12A12 plus C13A13. Very simple. If you know what is A11, it's the first element here, which is 1. So we have 1 multiplied by C11. A12 would be this element here, 2C12. A13 would be this element here, 0, C13. And what is C11? It's simply the cofactor. If you want to find the cofactor, remember the plus 1 and minus 1s. So this is plus 1, minus 1 and plus 1. We are only taking the first row. So we have plus 1. And if you still remember, C11 would be either plus or minus 1 multiplied by the minor. So in this case, it's plus 1 multiplied by the minor. And if you still remember the minor, we get it by cancelling out the rows and columns associated with the element and find the determinant of the remaining matrix. So let's do that. So we have 1 multiplied by C11. So we have plus 1 here. So we have only 1. And we need to find the determinant of the first element, minor. Okay. Now, if we still remember, C11 would be either plus 1 or minus 1 multiplied with the minor associated to the element. So in this case, we have plus 1. So plus 1 multiplied by minor 1. To C12 would be negative 1. So we have multiplied by negative 1, minor 1, 2. And because it's 0, then you see it's so easy. This would minimize our calculation time. This is simply 0. Okay, plus 0. So in this case, we have 1 multiplied by minor 1. So minor you get by cancelling out the first row and column associated with the element. And we have 1, negative 1, 3. Minor 1, 2. Row 1, column 2. We have 2 minus negative 1 is negative 2. Multiplied by the determinant of 4, 1, 0, 3. And here we have 1 times 3 is 3, minus negative 1, minus 2, multiplied with 4 times 3 is 12, minus 0. And we have 4 minus 24, which gives us negative 20. In the next example, we would expand the cofactors along the second column. Okay. So the second column is the one here. And we have matrix A here. The formula would be as such. So we take out all of the elements multiplied by the cofactor. So the element would be 2, 1, negative 1. Okay, we would add up all of this. And multiplied by the cofactor. If you still remember, the cofactor contains plus and minus 1, right? Cij is either plus or minus 1 multiplied by the minor. Okay, so this depends on I and j. So if you still remember, this was plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, and minus 1. So in the first case, we would multiply with minus 1. Second case, plus 1. And the third case, minus 1, multiplied by the minor. So this would be minor of the first row, second column, minor of second row, second column, and minor of third row, second column. And that's it. That's how you find the determinant of matrix A. Okay, so let's continue. 2 multiplied by negative 1 gives us negative 2, plus 1 multiplied by plus 1 gives us plus 1, negative 1 multiplied by negative 1 gives us plus 1. So now we simplifying the minors. So the minor of the element 1, 2, row 1, column 2 would be 4, 1, 0, 3, minor for element 2, 2, row 2, column 2 gives us 1, 0, 0, 3, minor for element 3, 2, row 3, column 2, 1, 0, 4, 1. Now, class, a smarter way to solve the determinant for matrix A using the expansion of cofactors along a column would be either to choose the column 1 here because it contains the value 0, or column 3 here because it contains value of 0. Okay, so you could do both of that on your own as a practice, and we'll do this together. So here we have negative 2 multiplied by 12 minus 0 plus 1 multiplied by 3 plus 1 multiplied by 1. This gives us negative 24 plus 3 plus 1. And the answer is negative 20. Now, I am pretty sure that you know by now that the determinant of a 2 by 2 matrix is AD minus BC. But what if we would like to use the formula that we have learned to find the value AD minus BC? So let's try that one out now. I think I would like to use the expansion of cofactor along the first row. If you still remember, what we do would be write out the elements. So the element would be A and B, right? And add up with the cofactors. So the cofactor would be plus 1 here, minus 1 there. So plus 1, minus 1, multiplied with the minus associated. So this would be minus 1, 1 and minus 1, 2. Okay. minor 1, 1 is simply the determinant of matrix D, which is D. So here we have A times plus 1 is A, and minor 1, 1 is D. Okay, so B multiplied by negative 1 is negative B. Minor 1, 2, cross this one out. So we have minor 1, 2 as the determinant of matrix C, which is C. And the result would be AD minus BC, as we have already known. Okay, so you could prove the formula of the determinant of a 2 by 2 matrix using the general rule to find the determinant of an n by n matrix. And we come to the last part of the video, and in this section we would learn two new things, which would be the inverse of a matrix. So the formula to find the inverse of a matrix is simply 1 over the determinant of the matrix itself multiplied by the adjoint of the matrix. So you would learn also to find the adjoint of a matrix. Now, what is the adjoint of a matrix? It is simply, if you still remember, what is this? These are the cofactors associated with the element of the matrix. So the adjoint of any matrix would be the transformation of the cofactors of the elements, which is very simple, and we could do this easily. So let's try out an example together. Let this be matrix B, okay, and we are supposed to find the inverse of matrix B. Now, before finding the inverse of matrix B, if you still remember, the formula to find the inverse of matrix B is 1 over the determinant of matrix B multiplied by the adjoint of matrix B. Okay, let's start by finding the determinant of matrix B. The smartest way would be, in my opinion, to expand the cofactors of the third row. Okay, so if you still remember, the formula would be the elements of the third row, which is 1 plus 1 plus 0. And remember the plus 1 and minus 1, it's the cofactors, yeah. Okay, so this would be plus 1 minus 1, this would be plus 1 multiplied by plus 1 multiplied by minus 1 multiplied by plus 1. Don't forget the minus. So this element would be row 3 column 1, row 3 column 2, and row 3 column 3. This could easily be calculated. 1 multiplied by 1 is 1 minus 3, 1. Okay, sorry, this one here. So we have 0, 4, 3, negative 1. 1 multiplied by minus 1 is minus. Okay, so we have 2, 4, 2 minus 1. 0 multiplied by anything would be 0. This would be 0. And so we have 0 minus 12 minus negative 2 minus 8. So this would be negative 10. Negative of negative 10 would be plus 10. So we have negative 12 plus 10 gives us negative 2. And that is the determinant of matrix B. And now let's find the adjoint of matrix B. I would rewrite matrix B again. Okay, Now, to find the adjoint of matrix B, we need the cofactors for each element of the matrix. And then we need to transpose this matrix. So let's start by finding C11, C12, C13, C21, C22, C23, C31, C32, and C33. If you still remember, we need to multiply plus or minus 1 with the minus associated with it. So this would be plus 1, minus 1, plus 1, minus 1, 1, minus 1, 1, minus 1, and 1. So minor 1, 1, cancel out the first row and the first column. We have 3, negative 1, 1, 0. Minor 1, 2, we have 2, negative 1, 1, 0. Minor 1, 3, we have 2, 3, 1, 1. Minor 2, 1, we have 0, 4, 1, 0. Minor 2, 2, we have 2, 4, 1, 0. Minor of element 2, 3, 2 and 3, we have 2, 0, 1, 1. Minor of element 3, 1, so 3 and 1, we have 0, 4, 3, negative 1. Minor of element 3, 2, we have 2, 4, 2, negative 1. Minor element 3, 3, we have 2, 0, 2, 3. So adjoint B would be the matrix of the cofactors, right? Okay, so we have plus 1 multiplied by 0 times 3 is 0 minus negative 1. We have here 1. And here we have negative of 0 minus negative 1. Which is negative 1. Here we have 2 minus 3, which is negative 1. And here we have 0 minus 4, which is 4. Here we have 0 minus 4, which is negative 4. Here we have negative 2 minus 0, which is negative 2. Here we have 0 minus 12, which is negative 12. Here we have negative of negative 2 minus 8, which is 10. Here we have 6 minus 0, which is 6. So adjoint of matrix B would be the transpose of the cofactors. And this would be, all of the rows would now become columns. 1, negative 1, negative 1. 4, negative 4, negative 2, negative 12, 10, and 6. So the inverse of matrix B would be 1 over the determinant of matrix B, which we got as negative 2 just now. multiplied by the adjoint. So 1, 4, negative 12, negative 1, negative 4, 10, negative 1, negative 2, 6. This gives us negative half, negative 2, 6, half, 2, 5, half, 1, negative 3. This would be negative 5. I missed out. Okay, so the inverse of matrix B is given as such. Now, to enhance our learning session, why don't we try one last easy question, a 2 by 2 matrix, okay? So, we have matrix A here, which is 1, 2, 3, 4. Okay, now help me find the minor of element 1, 2. So you need to locate element 1, 2, first row, second column, and then you need to delete the rows and column associated with it and find the determinant of the matrix, which is 3. Next, the cofactor of element 1, 2. If you still remember, it is the plus or minus 1 depending on the element itself. So we start with plus 1 and here will be minus 1. So minus 1 multiplied by the minor 1, 2. So this gives us negative 3. The determinant of matrix A is simply 4 multiplied by 1 minus 3 times 2, 6 is negative 2. The adjoint of matrix A, if you still remember, the adjoint of matrix A would be the cofactors. We still remember it is minus 1. Element 1, 1 would be power of 2, minor 1, 1. We already have the value of C12, which is negative 3. Okay, so C21 being minus 1 to the power of 2 plus 1 is 3, minor 2, 1. And the last element is element 2, 2. So negative 1 to the power of 4, minor 2, 2. This gives us 1, negative 1, and 1. Minor 1, 1 would be 4. Minor 2, 1 would be 2. Minor 2, 2 would be 1. Times 4 times 2 times 1. And this gives us 4, negative 3, negative 2, and 1. And so, to find the inverse of A is simply 1 over the determinant of A, negative 2 multiplied by the transpose of the adjoints. So let's do the transpose. 4 minus 3 minus 2, 1. And this gives us negative 2, 1, 3 over 2, and negative half. That's it. Thank you for your attention and I'll see you in the next video.